Okay, so today we're going to talk about the interpretation of the derivative. So here in this problem, it says here that we have a function f of t, and that is going to represent the number of inches of rain. So this is going to be important that here we're talking about the inches of rain. And then that has fallen since midnight, where time t is the time in hours. So we have that to be in hours. And so we know that T represents time. Interpret the following in practical terms giving units. So one of the things you have to remember is that something that we already know, the derivative means the slope, and therefore it's the rate of change, how things are changing. And then the inverse right here, that means that it's going to be the inverse where we've switched the X and the Y's. So those are things, important things for you to remember on here. So here is our function. Whatever we did, whatever the equation was, this is that when we put in 10 in there, I get 1.4. So what does this actually mean? And so what that actually means is this, that here, this is your t, because it's the f of t, and we know that t is time. So this one here is telling us hours. And this one here is hours since midnight. So here we have that since midnight, it's been 10 hours. So hours after 10 hours after midnight is actually 10 a.m. So this is saying that at 10 a.m., and then here it's equal to something. So what does it equal? F of t is the number of inches of rain. So this is saying that at 10 a.m., it has rained 1.4 inches. And so that's what it actually says. So in 10 hours after midnight, or actually 10 a.m., it has rained 1.4 inches. Notice how I have the units, notice how I have hours, and then after midnight, and what has actually happened. So that's not too bad. That goes from regular algebra. But here, this one here is saying a little bit different. Now we know that this is the derivative. This is not the same here. This one here and this one here are not the same because this one's saying the derivative. Now something has changed there. So when you interpret this, this is what happens 10 hours afterwards. This is the same thing. It's 10 hours afterwards. So it's still 10 a.m. So what's happening at 10 a.m.? And what it really is saying is that at 10 a.m., it is going to be raining at a rate. Anytime you have a derivative, you have to have that word there, a rate of, and then here are the inches. In this case, this has to be a rate. It has to be 0.1 inches per hour, because that's what we're talking about here. It's per hour here. And so we need to make sure that we know that that is also per hour. So the way we describe this is the rate at which the rain is falling at 10 a.m. or 10 hours after midnight is 0.1 inches per hour. Okay. Going to C. C, what does that mean? Well, C, this is the inverse. So why is that important? It's because it switches it a little bit, and sometimes we have the information switched a little bit. So now here, the 1, because we're switching it, the X and the Y, so the 1 no longer represents the hour. Now it represents the inches. The 3, now represents the hours. So now we have inches. Now we have inches here and we have time there. So this one here is going to be a little bit different. So this here says that when 1 inch of rain has fallen, 3 hours have passed. So 1 inch has fallen by 3 a.m. So either one would be okay. So that's what that one's saying. Now here, this one's a little bit different. Again, it's similar to this one because it does have the inverse, but it also has a derivative. So we know automatically that this is talking about a rate. So where are we going to put that rate in there? And so what this is saying is that it's been 1.4 inches and 3 hours. So what has happened? So the rain has fallen at a rate such that it will take 3 more hours for another 1.4 inches to fall. So what it's saying here is that the rain has fallen at a rate of, I guess we could say such that it will take 3 more hours for another 1.4 inches to fall. So it's going to be falling on there, at a rate of 1.4 inches, on there, but it's gonna take 3 hours for it actually to fall 1.4 inches on there. Okay, so the next one here, E, what does that mean? Well, now we have the two little dashes, so we know that's the second derivative. And so this here, this is the velocity of the rain. This is the rate. It's falling at a velocity of 1.4 0.1 inches per hour. It's a velocity. First derivative. The second derivative is talking about acceleration. So, is the rain slowing down or is the rain speeding up? And so that's what it's talking about. And this is what it's telling us. Notice how this one here is positive. That means that it's actually speeding up and therefore it's raining more. Here, this here is a negative. So the negative in their description of a sentence is never included, but we know that that one is going to be slowing down because negative means going in the opposite direction. And so this means that we're talking about acceleration, but it's still what we talk about is the rate at which the rate of the rain or acceleration is falling is decreasing because that's the negative. The decreasing, we no longer have to write the negative in there because that takes care of it by zero point 0.2. Notice how it's 0 and not a negative point 0.2 inches per hour at 10 a.m. Okay, so that's the rate at which that means that the rain at 10 a.m. is actually slowing down. It's still raining, but it's slowing down at that rate on there. So that's what they have on there. So let me point out one thing that students always seem to get confused. It makes sense in this situation, but when they apply it to something else, it gets a little bit confusing. So here's what we're saying here. So this here, if I go back to here and looking at that, this is talking about the hours and then the inches. Well, at 10 a.m., it didn't automatically, bam, there it is, 1 inches of rain. It actually took a while, and in this case, 1 hour to actually happen. So the 1.1 inches didn't happen at 10 a.m. It took a whole hour if it rained at that continuous rate of 1.1 inches per hour, if it was at that rate, then at 11 a.m., you would have 1.1 inches of rain in there. So, whenever you have a derivative, nothing happens at the time that's given. It always happens 1 hour later or 1 minute later, whatever the units are. That's when it happens. So, if I'm eating a donut, I don't automatically eat a donut. If it takes me a minute to eat a donut, I don't eat the whole donut at the beginning. It takes me till the end of 1 minute to actually eat the donut. That's the rate at which I'm eating it. So it is completely done after 1 minute. So make sure that you understand that anytime you're given a rate, everything happens 1 unit after. Okay, so let's do number 2 on here. And so number 2 is says here that suppose we have a function. We don't know what the function is, but this is the information that we got from the function. So here it says 24. When I put 24 into the function, it gives me 320. When I put 24 into the derivative, it gets me 5. So what does that mean, and how am I going to interpret it and estimate f of 26 and f of 23 if I don't know the equation? Well, that's really not too bad on there. And so we can make it into a word problem. We could say that it takes 24, I'm going to use that to be time, 24 minutes. In 24 minutes, I have made 320 cupcakes, let's say. So if I have that, that's how many I have in 24 minutes. Now, I could have slowed down, I could have sped up, I could have done something, but I know that the rate at 24 minutes, I am actually making 5 muffins per minute. So, or muffins per hour, whatever the units in this case, I chose minutes. Now, how realistic that is, I don't know, but that's what we said on there. So here it's saying that in 24 minutes, we have 320 cupcakes already done. The rate at which I'm making the cupcakes in 24 minutes is 5 cupcakes every minute. So I am estimating how many cupcakes do I have at 26 minutes. So at 26 minutes, I have, well, that's 2 minutes after 24. So that means I've made 5 cupcakes in 1 minute and then 5 more cupcakes. So that means that it is going to be 330. So we would say the 320 plus the 10 that it took me to, because that's the rate in which I'm doing it. By 26 minutes, I should have a total of 330 cupcakes. Now, estimate what's happening. Now, this one's going backwards. So if I'm going backwards at 24, I already have 320 and I'm at this rate. I don't know the real rate at 23, but I'm just going to estimate from this rate. So how much am I actually doing at 23? Well, since it's going backwards, I should have less cupcakes. So that means instead, I am going to take the 320 and I am going to subtract 5 cupcakes. So that gives me that I am going to, at 23 minutes, I only had 315 cupcakes. And there you go.